This video is all about covalent bonding. Covalent bonding is the sharing of electrons by two nonmetals. So a covalent compound is composed of elements that like to form covalent bonds. Covalent compounds contain all nonmetals. They fulfill the octet rule by sharing their electrons rather than giving and taking. You know, in ionic bonding, a metal gives electrons to a nonmetal, or a polyatomic ion like ammonium gives an electron to nonmetals or other polyatomic ions. But in covalent bonding, two nonmetals come close together and they share their outermost valence electrons. For example, the simplest covalent bonds, they involve diatomic elements. And so like hydrogen has just one outermost valence electron that we can draw as one dot. And another hydrogen will have one, and they'll come together and share these. And so we'll draw a line to represent a pair of covalently bonded electrons or shared electrons. And they can have unshared electrons as well. We'll get to all that in detail in our section on bonding. But for right now, it's sufficient to know that covalent compounds form what we call molecules. So we would call this a hydrogen molecule and a water molecule. Water's oxygen shares an electron with one hydrogen, and then it shares another valence electron with another hydrogen. So oxygen will share one of its with one hydrogen. Oxygen will share another valence electron with another hydrogen. And some of the electrons, here and here will actually be unshared. They share outermost valence electrons to meet their octet rule, or in the case of hydrogen, it was a duet. So that's where they get their formula from. The H2O is for two hydrogens, and then there's an assumed one oxygen, but we're really too lazy as chemists to write the ones most of the time. Okay, so the molecular formula for glucose is C6H12O6. There's also something called an empirical formula, or the simplest formula. Notice how these would all be divisible by 6. So I can divide each one of these by 6. 6 divided by 6 is C1, or we'll just write C for carbon. 12 divided by 6 is H2 for hydrogen. 6 divided by 6 is 1 again. So CH2O is the empirical, or the simplest formula for glucose. Let's just erase my mess and write CH2O. Okay, so molecular elements are elements whose smallest particles are molecules. Certain elements occur as diatomic molecules. These are so important. Di for two, atomic for atom. So these are two atom molecules. Let's even write that down. Two atom molecules. There are 7 diatomic elements. Some people call it like the rule of 7s. We find the element with atomic number 7. So we find nitrogen on the periodic table. Find those, nitrogen, and then make this figure 7. So make this little number 7 by going through nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So if you're counting, that's 6. So nitrogen, oxygen, fluorine, chlorine, bromine, and iodine are 6, and then hydrogen is the 7th element. So make a 7, these elements make a 7 on the table, these 7 diatomic elements plus hydrogen. I've heard some people call it H NOF and down to make the 7. So H NOF down to get your 7 elements. I was also taught a fun little mnemonic device when I was in school, and it was I brought chlorine for our new hot tub. So I brought chlorine for our new hot tub. Those are your diatomic elements. I2, Br2, Cl2, F2, O2, N2, and H2. I like my little sentence because oftentimes I don't want to look at the table to see if I'm in that NOF section. And so I found it easier when I learned to write reactions to look for those diatomics by just running through the sentence in my head. So, some people call it like Hunkle Briff. That doesn't work very well for me, but Hunklebriff is really, really common too. I tell you all of these because you might have other instructors that tell you different ways to remember these in the future. So H nuff down, the 7 that make a 7, the Hunklebriff, or the I brought chlorine for our new hot tub, whatever works for you to remember those diatomics. We just got to remember them. Okay, binary covalent compounds get named with prefixes. We name the first element, and the second element needs an IDE at the end, but we're going to use prefixes to indicate the number of atoms that we have present. So what are the prefixes? Mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, and octa for 8. So some of these might sound kind of familiar from geometry and things, but some of them might not. And so, we'll work on those slowly but surely. Now, if we have just one of the first element, mono gets dropped for the first element. We also drop the A at the end here, octa or hepta, if we begin with a vowel. So I'll show you, an example of that. So here's a good example. Let's name this compound. Okay, so we've got 1 carbon, but we don't want to use mono on the first nonmetal, so we'll skip it and we'll just call it carbon. And then we've got 4 chlorines, so we'll call it tetrachloride. So carbon tetrachloride. See if you can pause and try these on your own. You ready? Okay, we've got nitrogen first. We could say mononitrogen, but we always drop that at the beginning. No monos at the beginning. We have 2 oxygens, so let's say di, and then oxide. Nitrogen dioxide. Now this one's really similar. Mononitrogen, but remember mono gets dropped at the beginning. No mono at the beginning, even though there's 1 nitrogen, but there's 1 oxygen. You do put mono in the middle, so monoxide. And we can drop the double O. We don't need to put a double O. We just say nitrogen monoxide. Sometimes folks ask me, why do we drop that first mono at the beginning? And I often say, because carbon monoxide. That's why. Most of us have heard of the poisonous gas carbon monoxide. And know that we should have carbon monoxide detectors in case our furnace goes on the fritz and it's doing incomplete combustion and producing a lot of CO. CO gas is really deadly and it's really tricky. And I didn't mean to put that line down here. In that it's kind of hard to detect and kind of unpredictable. Even firefighters hate it when they come looking for carbon monoxide because it's so tricky. It can settle in pockets in your home. And so that's why you have those detectors. Okay, PCl5. Okay, so we're going to call this one phosphorus. We don't put that mono, phosphorus. And then we'll do, whoa, why did I not? So let's just erase and try this again. Phosphorus. And then we need penta, 5. Pentachloride. We don't put mono at the beginning. Then we'll have phosphorus, and we'll have trichloride. And then lastly, we do have 2 iodines, so we need to indicate that with diiodine. And then 7 up here is heptafluoride. Watch your spelling on fluorine. It's F-L-U-O-R, fluoride. That one gets folks sometimes. Flour is spelled with an O-U, and fluorine is spelled with F-L-U-O-R. So with fluorine. Fluorine spelled F-L-U-O-R. Okay, so fluorine with a UO, not like flour. Oh, speaking of spelling, I got an extra O in here. Man, phosphorus is like giving me trouble here. It's ORUS. Um, so that concludes our portion on covalent molecules, on naming and writing the formulas for covalence.